Here is a question on Thevenin's theorem applied to an AC circuit. Here we have a 9 volt AC source. 9 volt is the RMS value, and then these impedances are this is minus J6 ohm, this is 8 ohm, and this is plus J6 ohm. We have to find the value of ZL, this load impedance for which the power consumed in ZL will be maximum. Let me call these two nodes as A and B. Now let us find out the Thevenin impedance between A and B of this circuit inside the box. Okay, so Z Thevenin, that is the impedance between A and B, how much is that? So between A and B we have two branches in parallel. One is J6 ohm, and that is in parallel with this other branch with impedance 8 minus J6. 8 minus J6, this is in ohm. Okay, so this is equal to J6 into 8 minus J6 divided by J6 plus 8 minus J6 ohm, which is equal to 4.5 plus J6 ohm. Now, for which value of ZL power consumed in ZL will be maximum? So the required value of ZL, that should be equal to the complex conjugate of the impedance between A and B, that is ZAB star. This comes from the maximum power transfer theorem, and so this should be equal to 4.5 minus J6 ohm. So the required value of ZL should have a real component equal to 4.5 ohm, and the imaginary component should be minus 6 ohm. Now for this particular value of ZL, how much will be the power consumed in ZL? For that, let us first find out the Thevenin voltage between A and B. Okay, so V Thevenin between A and B is how much? So Thevenin voltage is the voltage between A and B in the absence of this ZL, this load. Okay, when this load is not connected, then how much is the voltage between A and B? So for that we see we have a voltage source, and then some impedances are connected in series, so we can apply potential divider rule. Okay, so this 9 volt, okay, so 9 volt divided by minus J6 plus 8 minus J6 plus 8 plus J6. Okay, this is basically the current that would flow here in the absence of the load. Okay, now this current multiplied by this impedance J6 into J6, this will be the voltage between A and B in the absence of ZL. How much is this? Okay, so here these two terms cancel. Okay, and we have J9 into 3 by 4 volt. That's the Thevenin voltage. Okay, now when this load is connected, when ZL is connected, how much will be the load current IL? Okay, so that will be this Thevenin voltage J9 into 3 by 4 whole divided by the Thevenin impedance, which is 4.5 plus J6 plus the load impedance, which is 4.5 minus J6. Okay, so this term gives the current IL. Okay, here these two terms cancel, Now this is IL. If we take the square of the mod value of this current, that means square of the modulus of this current, and if we then multiply it with the resistance of this ZL, that is 4.5 ohm, that will be the load power. Okay, so you can now simplify it and you will get 2.53125. This is in watt, this was ampere. So the answer for the last part, power dissipated in ZL, is 2.53125 watt.